Um, you've got to be here. I've had a couple people reach out to me that, of course, are not here today, that wanted to take the exam end of the week. We've had a couple meetings. I actually just got out of a staff meeting, so the registrar really just discourages that. They're the ones that set the schedule. So at this point, I expect everybody to be there, and it's a final exam. And if you're not, then the dean and their office will get involved, okay? Because they're the ones that sets it. And they just reminded us to make sure the students show up when they're supposed to show up, okay? And everybody here is good, so I don't have any worries with you guys. So I wanted to start here, okay? And just point out a few things. So I'm going to write some things down here. They're not in any sequential order. They do not correspond to questions on the final exam. In other words, whatever I write in one will not be question one on the exam. These are just things that I want you to focus your attention between now and Monday. All right? I'll give you some reference numbers in some cases I won't. Like page numbers, table numbers that I want you to kind of do a little bit of a deep dive into, okay? So just a reminder, I talked about this last Monday, I guess it was Monday. Male reproduction, be aware of where in the testes this happens. So essentially in the seminiferous tubercles are where spermatogenesis occurs. All right? And so you'll see these things like Leydig cells, they produce testosterone. The Sertoli cells I mentioned, they produce inhibin. All right? And that's important to know because that's kind of a regulator on hormones with regards to male reproductive. The Sertoli cells are sometimes called nurse cells too, like a nurse, doctor nurse. And the reason they're given that name is why. By the way, this is interactive. I'm not reteaching anything. So I'll ask you, you tell me, that type of thing. Sertoli cells. They're called nurse cells. Why do you think they're called nurse cells?
They provide nutrients and vitamins to help the cell develop.
Nutrients, vitamins, and protection too. Protective, supportive, that sort of thing. So Sertoli cells are very important in the early stages of spermatogenesis in the fact that they're like an incubator. That's why they're called nurse cells. All right? They're like the thymus, akin to the thymus gland with T cells. They provide an environment of protection, etc., growth, maturation. All right? So remember this. The other thing is know how testosterone production is affected vis-a-vis the relationship with LH and FSH. Remember, those two hormones are common in both female and male. Male with spermatogenesis, female with oogenesis, and the development of the egg. So you've got to know that track of both of these, all right? So at least you know the starting point, then what happens along the lines, okay? So have a look at that before the exam, please. And in addition to that, know, when spermatogenesis is involved, so I'll just put that down. Remember we started with the primordial germ cell, and we went from there. Okay? So know the whole, I'm not going to go over the whole thing, but spermatogonia, etc., all the way down to the end point where the sperm is developed and it's released into the lumen. Bless you. And the lumen, the one particular image that I recall putting up there, it's the lumen of the seminiferous tubercle. Okay? So that's the first thing. Secondly, TSH. Where's this hormone found? Pardon? Goes to the thyroid. Where does it come from? Where does it originate from? Where does it originate from? Where do all the anterior and posterior pituitary gland hormones originate from? Hypothalamus. Then they go to their differentiated part of the pituitary. All right, so you have to know TSH, the thyroid, and then how that affects the production of T3 and T4. And related to that, know the difference between hypo versus hyperthyroidism. All right? And I made reference to Hashimoto's disease and Graves' disease. You may not get a specific clinical about that, but you got to know if you're low in one of these hormones, what is the effect? Okay? Number 3, FSH. Where do we see this hormone involved in? Well, there's one, right? Where else do we see follicle stimulating hormone? Where else do we see the FSH? What other system do we see it in? I just mentioned it. We see it in male and female. What's FSH used for in the female reproduction? What's that hormone essential for?
Ovulation?
True. Follicle development. Follicle development. The follicle development that we're talking about is the ovum. You need FSH for that. Ovulation is more related to the spike in luteinizing hormone we saw at day 14. Remember? When that spikes, that usually initiates ovulation. Number 4. Lipid soluble versus water soluble. What was the big distinction with those two? How they cross the cell membrane, right? The lipid soluble hormone had a free pass across the cell membrane, remember? The water soluble hormone needed a little assistance. In other words, it had to latch onto a receptor within the cell membrane and from there get across the cell membrane into the inside via CAMP, first and second messengers. Remember? I had the graphs up that day and talked about that. So that's what I'm looking at for those. Know the differences between those two. 5. When I first started the section on endocrine, so there's most of these questions are going to be from endocrine and reproduction. Okay? That's where the focus is. So, nervous system versus endocrine. And the very first day I talked about in here about a few differences. What's one? When we compare and contrast nervous system with the endocrine system. What's a characteristic of the nervous system? Come on, not all at once.
Electrical impulses. Electrical impulses in the nervous system.
True. Yeah, that's true. What's the mechanism?
The neurotransmitter.
Yeah, so this one will use like maybe a dopamine, acetylcholine, the synaptic cleft, crossing the synaptic cleft to the adjacent neuron. All right? And this relies on hormones. So then you take it from there. Neurotransmitters are what?
Fast.
Quick or slow?
Fast.
Fast in comparison to hormones. Hormones may take, remember,
Seconds, hours, or days.
second hour, days, in some cases weeks, residual hormones stay. Neurotransmitter is instantaneous, milliseconds. Okay? So that's what I mean by compare and contrast those two systems, nervous system with endocrine / hormone. All right? Number Number 6. What the heck is that RSS? The renin-angiotensin-aldosterone system. We talked about that. That's part of endocrine too, even though we also brushed on it in the renal section, urinary. What is that? What's the first hormone that gets this process going? What do you need to start this process? And why is this process important? What does it regulate in our body? What does the RAAS regulate? What's the first thing? What's the R stand for? Renin. Renin is the first ingredient in this system that you need. It leads to everything else cascading down the system. Remember, that's in the JG cells, the juxtaglomerular cells. Not to be confused with the macula densa cells that keeps an eye on sodium and chloride leaving the kidneys, right? This is different. So don't confuse the two. These come from JG, renin. What does renin lead to? Angiotensinogen, right? The inactive form of angiotensin. Angiotensin 1. Angiotensin 2. What's the end product of this?
ADH.
ADH. Antidiuretic hormone. Why would you want to produce ADH? Why does the body produce ADH? What is it trying to regulate?
Reabsorption.
Of?
Sodium and water.
Reabsorption of water and sodium. Why?
So we're not dehydrated.
Not dehydrated. Dehydration leads to what kind of urine?
Starter blood urine.
Very concentrated, very dark in color, very high in turbidity. Bless you. So this system is important because it regulates, and it also has another effect of regulating what? Blood pressure. So along the way here, you'll need things like, of course, ACE, which is the angiotensin converting enzyme. All right? And this is found in the lungs, and I talked a lot about blood pressure medication makes people wheeze, and on the directions that say may make you cough, may make you wheeze, short of breath. That's because of the effect that blood pressure medication has on the ACE. Remember me talking about that? So know this, all right? There'll be a question on there at least, and the steps along the way. You know, no, this is from the liver, of course, the angiotensinogen. All right? So know that one. Number 7. No PTH. What's that hormone? What's PTH? Parathyroid hormone. Where does that come from?
Parathyroid.
Parathyroid, which is where in relation to the thyroid gland? Anterior, posterior, medial, lateral.
Anterior.
Pardon?
Anterior.
Where's the parathyroid? Is it in front? It's behind it. Yeah, it's behind the gland. It's smaller, but it's behind the gland. All right? In relation to this, what does the thyroid gland secrete? The parathyroid secretes the gland that is named as the hormone that is named after. What about the thyroid gland? What's the key hormone that's secreted from the thyroid? Calcitonin. Why is calcitonin important?
Bone density.
That's one of the things, right? Bone density. The relationship of osteoclasts and osteoblasts. Remember talking about that? making new bone, reabsorbing bone, or reabsorbing calcium to make new bone. All right, so know obviously the difference between parathyroid and thyroid. That shouldn't be too bad. But know the individual hormones each one of these releases. And when I say releases, what does the hormone act upon afterwards? So the textbook has got a lot of different illustrations, some of which I showed in class, that show like if they're negative feedback loops, you know the ones I mean? What's the organ it acts upon, and it's got like the arrows. It would be a really good idea to know those. Because you can just know the glands and know the hormone, but then what does the hormone act on if it's low or high? So spend a lot of time on the weekend focusing your attention on those. Not just thyroid, parathyroid, but other things too. All right, it'll give you good feedback, so just don't know the ins and outs. Take it down another layer as far as, okay, now I know where they come from, what do they act on? I'll put 8 up here. Number 8 is all right, some of the structural anatomical features we talked about, like the infundibular stalk that connects the two. They're very much intimately connected. But know at the cellular level what happens with the hypothalamus vis-a-vis the relationship to the pituitary glands, anterior pituitary and posterior pituitary. I don't remember if I left this up here or not. Okay, back to my last paragraph. This is table 18.3, page 657 in your textbook. And I pulled a question from that graph. Want to take a picture of it, go ahead. But know what each one releases. And then the other part, why I have this stuck up here, is know whether there's an inhibitory effect. Some of these have an inhibition or an inhibitory effect, some do not. Like LH, FSH do not have an inhibitory effect. All right? And related to that, are these positive feedback loops involved, or are they negative feedback loops? We talked about prolactin until we're blue in the face. That's obviously positive feedback from the posterior pituitary gland. Labor, etc. We've talked about that. All right? So know which ones are which. But that's page 657. Next. Oogenesis versus spermatogenesis. So this is kind of what we've been focusing on this week. That should be pretty much front of mind and fresh in your minds. Know the difference 1 week after we get past the LH and FSH. Now for this one, oogenesis, you may want to go to, let's see here, table 28.1. This is in your textbook, page 1127. And for spermatogenesis, have a look at table 28.5, and this is on page 1012. All right? That will clearly kind of go through each of these processes. So please have a look at those too, okay? Be able to differentiate. Where does the primordial follicle lead to? We talked about primary, secondary, tertiary, and the tertiary bursts. And that leads to the corpus albicans, or corpus luteum, then the corpus albicans. And then the importance of the corpus luteum and those 4 hormones that it releases: inhibin, relaxin, progesterone, estrogen. All right? So know which each of those comes from with regards to this. all right? The oogenesis is the development of the egg, of course. Spermatogenesis is development of sperm. But know what each does after that, all right? Okay, so that's number 9. Number 10. So we talked about in male reproduction, the erection. I had the graph up there with the muscles and the corpus spongiosum. And the main thing I talked about was that there's 2 different nervous systems involved. Parasympathetic nervous system regulates the act of the erection. The act of the ejaculation is governed by the sympathetic. So they're governed by 2 different nervous systems in male reproduction. So go, I don't know if I have a page number for this one. I do. Page. I've been multitasking all day. I was in a meeting and I was doing all this. Dr. Montoya's like, yeah, what are you up to? Oh, I'm working on this. He's like, okay. Okay, so have a look at that, and that'll kind of summarize the nervous system, all right, of males. This is kind of related to what I said, number 11. Positive feedback loop, and this is related to hormones. So related to the hormones I talked about. And there is also a positive feedback loop in part of female reproduction related to some of the hormones. So have a look at, I believe it's on 1127 or 1128. I'm not positive, but have a look at that. Okay? Page. All right? Next. Oh, man. Can I get rid, you want to take pictures of this, or?
No.
Everybody, are you good, Isabella? You got all this?
Positive feedback. Okay.
I'm going to take the left side off.
Oh, yeah, you're good.
Why is everybody yawning today?
Because it's about time for anything.
Amen, sister.
Okay. So the adrenal gland we talked about a week ago. It sits on top of the kidneys. Release of cortisol and, helps regulate stress. But what I really want you to do is focus on things like these 2 things, okay? Glucocorticoids, mineralocorticoids, where are they released from? Like you've got different parts, different layers or zones of the adrenal gland. For example, zona reticularis. All right? Each one of those specifically has either a glucocorticoid or a mineralocorticoid. That's up to you to find out. So review that section too, please, okay? There'll be another section on female reproduction system, cycle. Did I save something for that? Maybe I did not. Okay, so what I'm talking about is what I had up the other day. I'm not sure of the page on that. Where it separates the development of the ovary on the top part to the uterus on the bottom part. And the changes each one of those undergoes during the cycle. That's the graph I mean. Where it shows the spike of LH, all right? Know that. Have a look at that and know that. Read it over and make sense of it. Don't just look at it, say, okay, this has to be released because this hormone's down. Estrogens are high, so that regulates this. That's what I mean. All right? So plug the hormones into that graph. on underneath that, what happens to the body during that time, okay? All right, another section will be on the endocrine glands and their respective hormones. So, like, this is what I mean by this. So note each one of these. This is just anterior. Posterior is easy, ADH and oxytocin. Know these 7 and know which each one of these comes from. So like human growth hormone, for example, is the first one. Released in response to secretion of growth hormone releasing hormone, GHRH, acts on body tissues by stimulating it to synthesize, secrete insulin-like growth factor. Thyroid, CH is released in response to secretion of thyrotropin, releasing hormone, TRH, which stimulates thyroid to release T3 or T4, T3 and T4. So go through each of these, and you know better than me how you're going to either memorize these or make it make sense. Whether you look at a table in the textbook, or a lot of you draw things out. But you got to know which each one of these acts upon once they're released. All right, and that's not too bad. I mean, obviously, you can separate LH and FSH. You're probably going to sex glands. Adrenal is pretty simple. Prolactin is breast tissue for mammary, etc. Okay? So have a look at that. That's what that next section means. You could get a multiple question regarding these, and you got to plug them in. One of those questions that students hate. Because if you miss, you get one wrong, then you're all jumbled up, right? So chances are that'll be in the form of a question where it's out of 8 or 7 or whatever. And you got to take the hormone and corresponding, okay? Number 15. Let's see here, what else is there? So related to that, I guess I could just go down from there. So there'll be a couple of questions on this. So you could get ADH, you could get things like inhibin, relaxin, prolactin, and you may have to answer either what it does or what it acts on or where it goes to. So that's why you got to know it all. All right? So it'll be like a mix and match type of thing. Good here? Okay. All right, 15. Okay, you will get a clinical question. I think it's in the form of essay, I'm not for sure. And so what the question will focus in on is the reproductive cycle of female the relationship of estrogen and progesterone, and I'm just going to give you some things to focus on. So figure 2824, that's on page 1139. Figure 2826, that's on page 1141. So, like for example, more estrogen prompts the release of more GnRH. Things like plugging in the different hormones into if they go up, if they go down, what happens hormonal wise. And then you will wear your future clinician hat, and I talked about this Wednesday, how would a birth control pill fit into the scheme of hormones? All right? So we touched on that on Wednesday, how the birth control pill works at the different stages. So you'll get a chance to explain this, how it works into the female reproductive system related to hormones. Okay? And that shouldn't be too bad, I don't think. But you got to know how things work to begin with, all right? Know how each hormone works. So I've talked about female reproduction cycle of females now 4 times, maybe. So I would bet there'll be questions on that. This one for sure. All right, so take the time, write notes out, go through it, so you're going to be able to spew it out if it's an essay question, which I think it is. And some students love those, because some students get a chance to BS, and other students get a chance to actually write what they know. All right? And you got to know how to do both of those things. You got to know how to rationalize things and write at the same time without the filler. Okay? And be very succinct in your answers. There's another section on endocrine again too, so I guess I could put 16. So this one again is endocrine, not estrogen, endocrine glands, secretions. So this one's basically all about secretions. And that's why I've referenced you throughout this, the tables and the pages, so you go right to them and say, okay, boom, boom, boom. So a lot of the focus is on endocrine, and a lot of focus is on reproduction. Within reproduction, female probably more than male questions. All right? Any questions? So that's it. Mhm.
Will there be like any urinary system on it?
No. I figured I looked at the things and everybody did really well on that quiz, so I'm going to leave that. So I'm going to focus on 2 things that are most recent. And I don't think that's that bad. Of course, I'm not taking the test, but I think it's a fair test. I really do. Some of you did really well on the practical and are chomping on the bit to get the grade that you want.